Hi guys, in this video we're going to have a look at the equation of a straight line, but in this particular video it's the perpendicular line. Okay, so a couple of things we need to know before we get started is hopefully you can remember the general equation of a straight line, y equals mx plus c, where m is the gradient, so the slope, how steep the line is, and c is where the line crosses the y-axis, called the y-intercept. Okay, so hopefully if you've seen my other videos, you'll have seen that before. The second thing we need to be aware of is what does perpendicular actually mean. So perpendicular just means that if you have two straight lines like I've got here, and they cross each other, where they cross, it will be 90 degrees. Okay, so if it's a vertical and horizontal, they're perpendicular. I've done one here, so it's just slightly rotated around. And again, these two are perpendicular because if I draw them, where they meet is 90 degrees. Okay, so that's what perpendicular means. And we're going to be working out the equation of perpendicular lines. So that's what the equation of a straight line is, and that's what perpendicular means. And you also need to know this fact here. So m1 times m2 equals minus 1. So all that means is the gradient, remember m is the gradient of the first line times the gradient of the second line, or the perpendicular line. If you times them two together, you should have minus 1. Okay, so that's what we're going to use to help us find the perpendicular gradients of these four here. Okay, so if my first line, or m1, has the gradient of 2, and I want to know the perpendicular gradient, or the gradient of the perpendicular line, all I need to do is go, okay, well, let's call the first line 2, so m1 is 2. I times that by my perpendicular gradient that I want, and that's going to equal minus 1. So by a little bit of rearranging, 2 times my perpendicular gradient equals minus 1. So if I'm timesing by 2, just do the opposite and divide by 2. So my gradient will just be minus 1 over 2. So basically minus 1/2. Simple as that. Same thing for the next one here. If the gradient of one line is minus 5, then the perpendicular gradient, well, I times the two together, must be minus 1. So all I do is just divide by minus 5. So the gradient will be minus 1 over minus 5. Minus 1 divided by minus 5, well, a minus divided by a minus is a positive. So it's just 1/5. Okay, so that's quite nice and easy when they're whole numbers. Gets a little bit trickier when they're fractions. So again, if I'm doing 1/3, so it'd be 1/3 times by my gradient, or my perpendicular gradient, and that's going to equal minus 1. Essentially what I'm doing is exactly the same thing. I'm dividing by a third, so I'm going to have minus 1 divided by 1/3. So we're just dividing fractions. So if you're unsure of how to divide fractions, obviously look at my dividing fractions video. But essentially we consider minus 1 to be a fraction by putting it over 1. And I'm going to do KFC. Keep the first one the same, flip the second one, and change the divide to a times. So minus 1 times 3 is minus 3. 1 times 1 is 1. And then minus 3 divided by 1 is obviously minus 3. Okay, so the gradient of the perpendicular gradient will be minus 3. Now that's a lot of effort, and there is a simpler way, which is I'm going to show you now. If you want the perpendicular gradient, yes, you can use this formula and do it that way, absolutely fine. However, the other way you can do it is take the gradient that you've been given, flip it, and if it's a positive, make it a minus. If it's a minus, make it a positive. Okay, so for example, this one, if I had 2, consider it as a fraction, so 2 over 1, flip it, so it becomes a half, and because it's a positive, make it a negative. There we go, minus a half, minus a half. Same thing for this one, consider it as a fraction, flip it, so it would be minus 1/5, and because it's a minus already, we need to make it into a positive, so it'd be plus 1/5, which it is there. Same thing for this one, if I have a third, flip it, so it's 3 over 1. Because it's a positive, make it a negative. So minus 3 over 1 is minus 3, which we had here. So that's the quick way of finding the perpendicular gradient, which is what I'm going to use for this one here. So if I have minus 3 over 5, what I'm going to do is I'm going to flip it. So I have 5 over 3, and because it's a negative, I'm going to make this one positive. So that's minus, that's a positive. So my gradient of my perpendicular line would be 5 over 3. So that's the quick way, and that's the rule that I'm going to be using to do the rest of the examples I have for you guys. Okay, but that's why, because gradient times the perpendicular gradient equals -1. And you can always use that as a check to make sure you're correct if you're ever unsure. Okay, so let's get stuck into some examples. So I want to find the equation of a line that is perpendicular to this line and goes through this coordinate here, or this point 6, 3. So the first thing to do is find the gradient of this line. Okay, now using our formula or general equation here, m is the gradient, so in this case -3 is the gradient. So the gradient of the first line is -3, because it's what's in front of the x there. Okay, now if I want the gradient of the perpendicular line, exactly the same thing we do over here. So I'm going to consider that to be a fraction, and I'm going to flip it, so it'll be 1 over 3, and because it's a minus, I'm going to keep it as a positive. So that is the gradient of my perpendicular line. Okay, 1/3. Let's plug that or substitute that in to our formula. So y equals 1/3 x plus c. Well, remember, c is where it crosses the y-axis. Now, to work out c, as you might have seen from my other previous videos, if we've got a coordinate, all we do is substitute these values into here. So don't forget, with a coordinate, you have an x value and you have a y value. So that's all I'm going to do. I'm going to substitute the x and y into this equation so far. So y is going to be 3, and then it's 1/3 times x. Well, x is 6, and then I'm going to plus c. A little bit of tidying up. Well, 1/3 times 6 is just going to be 6 over 3 plus c. Well, 6 divided by 3 is 2. And rearrange it to get c on its own. So if I've got plus 2 here, I'm going to minus 2 from both sides, which gives me 1 equaling c. Don't forget, though, to put it all back together. So y equals, and the gradient was 1/3, then x plus a c, and we just worked out c is 1, so plus 1. So that would be the equation of the line that's perpendicular to that one and goes through that point there, 6, 3. Okay, that's probably the most common type of question that you can have. So let's go through a few more examples and have a look. So that's that one. And let's start off with these two here then. Okay, so one very similar. Again, I want the equation line that's perpendicular to this line and goes through this point here. Okay, so I'll just pick this as an example because it's got a fraction as the gradient. So again, what's the gradient of this one? It's 2/3. So to work out the perpendicular gradient, I'm going to flip the fraction. So it's 3 over 2, and because that's positive, I need to make this one negative, okay, and that's going to be my perpendicular gradient. Let's put that into the general equation for a straight line. So y equals mx plus c. We just worked out the gradient's minus 3 over 2, so let's put that in. And exactly the same before, because I've got a coordinate, I have an x value and a y value. So let's substitute those in. So y is minus 2 equals minus 3 over 2 times 4 plus c. Okay, bit of tidying up. Minus 3 over 2 times 4 would just be minus 12 over 2 plus c. If you're unsure about these, look at my multiplying fractions videos. And again, a little bit of tidying up. Minus 2, well, minus 12 divided by 2 is minus 6. And again, rearrange to get c on its own. So if that's minus 6, using the balance method, if I add 6 to both sides, I'm left with 4 equals c. So once you've worked out c, don't forget to go back up here and put it all together. So y equals minus 3 over 2, or minus 1.5, whatever you fancy, x, and then plus 4. Okay, and again, there you go. There's the equation of the line that's perpendicular to that one and goes through that point there. Okay, let's have a look at this one then. So, line A goes through the points 5, minus 2 and 11, 1. Line B is perpendicular and also goes through the point 5, minus 2. What is the equation of line B? So it's exactly the same concept we're going to be doing here. However, I don't have the equation of this line to get the gradient from. So I'm going to have to use these two coordinates to work out the gradient of line A. So if I just call it A, Okay, well let's keep it with m. So m is the gradient. Okay, and I'm going to work out the gradient of this one here. So if you don't know how to do this, make sure you have a look at my video on finding the equation of a straight line. I think it's part 2 where we do this. Essentially, to work out the gradient, we look at the change in the y. So it's -2 to 1, so it's a change of +3. And then you divide that by the change in x. So from 5 to 11 is 6. Okay, so the gradient of line A going for these 2 points here, we look at the change in y, so it goes up 3, and we divide that by the change in x, which is 6, and simplify that to a half. So the gradient of line A is 1/2. So if I want the gradient of the perpendicular line, as we've done before, I flip that to be 2 over 1, and because that one's positive, I just make that one negative. And -2 over 1, or -2 divided by 1, is just -2. Once you've got the perpendicular gradient, it's exactly the same steps we do over here. Let's substitute it in. So I'm going to have -2x plus c, and we're told that line B goes through the same coordinate here, 5 minus 2. So there's going to be my x value, and that's going to be my y value. And we're going to put that in. So y is -2. And then -2 times x, well x is 5, plus c. Bit of tidying. -2 times 5 is -10. And I want to get c on its own, so I'm going to do the opposite. And I'm going to add 10 to both sides, which leaves me with 8 being c. Don't forget to go back and put it all together. Well, I'll put it down here. So y equals the gradient, which was found -2x plus 8. Okay, so that's what to do if you haven't been given the equation of a line. We've got 2 coordinates, find the gradient of that one, then find the perpendicular gradient and substitute it in with that point, and you're in business. Okay, so let's have a look at 2 more examples that are just ever so slightly different. So the first one we're going to have a look at now is when you've been given a line, in this case line A, and we're told that line B is perpendicular to line A, and it goes through the point 5 minus 1, and we've got to work out the equation of line B. So just as we did before with the 2 coordinates, we need to work out the gradient of this line to help us work out the perpendicular gradient. So again, if you've seen my other videos of how to work out the gradient from a line like this in the equation of a straight line, I think part 1, okay, this will be the same thing. If not, make sure you go back and have a look. Essentially what we do is we find 2 coordinates that are on the line. So I'm going to go with -1, 2, and 1, 6. I'm going to draw my triangle, and I go left to right. So what is the change in y? Well, it's 4. And what's the change in x? Well, it's 2. So exactly the same method, really, as the previous example we just did. Okay, so to work out the gradient of this line, I do the change in y, which is 4, divided by 2. So 4 divided by 2 is obviously 2. So the gradient of this line, line A, is 2. So if I want the perpendicular gradient of the line B, remember, I think of that as a fraction. So that's 2 over 1. I flip it, so it'll be a half. And because that's positive, I make that one negative. Okay, so that's going to be my gradient of my perpendicular line, or line B. Let's substitute it in then and start finishing off the rest of it. So y equals -1/2 x plus c. We're told that line B goes through this coordinate here, 5 minus 1. So obviously 5 is the x value and -1 is the y value. Let's put it in. So -1/2 times the x value, which is 5, plus c. Okay, so -1 equals... Now you can keep this as a fraction if you want, but I'm going to change it to a decimal in this case, A, to show you both ways, but also I think it's a little bit easier. So -1/2 times 5 would be -2.5 plus c. So you can keep it as a fraction if you wish, entirely up to you, but I think the decimal is a little bit easier here. So -2.5, if you want to get rid of that to get c on its own, I need to add 2.5 to both sides. So -1 plus 2.5, 1.5 equals c. Don't forget to go back and put it all together. So y equals -1/2 x, or -0.5x if you prefer, plus 1.5, or 3 over 2 if you want to convert back to a fraction. Entirely up to yourself. Okay, so that's that one when you've got a drawing. Now this one here is tricky. Now it looks horrible, but it's using exactly the same skills as we've just been doing. So I've got coordinates A, B, and C of 2, 9, 10, 7, and 6k. AB is perpendicular to AC, and we need to work out what k is. Now what I would do in this case is just do a very quick sketch. You don't have to do an exact drawing, but a quick sketch is quite handy to see visually what's going on. So that's what I'm going to do here. So point A is 2, 9, so I don't know, let's go like 2, 9, like something like there, where that's 2 and that's 9. Okay, x2, y9. So that's point A. Point B is 10, so I'm going to come over here, and 7, so it's obviously going to be less than 9, so I don't know, let's go there. Let's say it's just a quick sketch, and that's going to be B, where that's 10, and across there will be 7, okay? And obviously I can't plot C because it's 6k, I don't know what k is, that's what I need to work out. So one thing I can do is work out the gradient of AB, because I know AB is perpendicular to AC. So if I work out the gradient of AB, I can then work out the perpendicular gradient of line AC. So let's do that in exactly the same way I did on the previous example over here. I know those two coordinates, so I'm going to draw my triangle. What's the difference in y? Well, to go from this point to this point, it goes from 9 to 7. So it actually goes -2, and then from A to B on the x, well, it's 2 to 10, so it's going to be 8. So the gradient of AB is going to be the change in y -2 over the change in x, which is 8. Just simplify that to be -1/4. So the gradient of AB is -1/4. So if I now want to work out the gradient of AC, which we're told is perpendicular, I can then work out the gradient of that. So let's do that down here. So the gradient of AC, we call it M2, but we're just known as AC, is going to be flipping that, so it'd be 4 over 1. And because that's a minus, this is a positive. So I can leave it as 4 over 1, or just tidy it up to be 4. So the gradient of AC, or the line AC, is going to be 4. Let's substitute that in. So y equals 4x plus c. Now, you may be thinking, well, hang on a minute, what coordinate do I then put in for y and x if I don't know what y is? Good question. And this is where you need to spot that the line AB is perpendicular to AC. The coordinate A is in both lines, so that is the coordinate I'm going to use to substitute into this bit here, in which case A has the x coordinate of 2 and the y coordinate of the y coordinate of 9. So that's what I'm going to put in, because AB, AC, A is in the same of both. So let's do that. So y is 9, and 4 times 2 plus c. Bit of tidying, 4 times 2 is 8 plus c, so -8 from both sides. So 1 equals c. Okay, so the equation of line AC is y equals, we worked out the gradient to be 4, so 4x, and then c is 1 plus 1. So that is the equation of line AC. So how does that help us work out k? Well, I know that 6 is the x value. So let's substitute that into this equation and see what happens. So y equals 4 times x, well, x is 6, plus the 1. Don't forget to do your bid maths, so 4 times 6, 24, plus the 1, so y equals 25. So the y coordinate is 25, which is what that would be there. So k equals 25. Okay, so it's a decent question, this, very juicy. I love a good question like this, and that's how you do it. Okay, do a quick sketch to help you understand what's going on. You also spot that it is a negative gradient, hence why that needs to be a minus, so that does help. Work out the gradient of that one, work out the gradient of the perpendicular one, and then spotting that the AB and AC has the A coordinate the same. Okay, and if you think about it, if you were to plot this point of 6, 25, it would be somewhere, I don't know, over here somewhere, and it would look right, it would be perpendicular. Okay, guys, so hopefully that helps and gives you some ideas of how different types of questions can be asked. Cheers.